Welcome to my channel Chemistry Class. Welcome back to Chemistry Class. My dear student, I hope you are doing well. So, in the last lecture, we studied the Arrhenius concept of acids and bases, where we learned that acid produces H plus ion, while base produce OH negative ion in water. But today we are going to study another concept of acid and bases, which is Bronsted-Lowry concept of acids and bases. But dear student, this concept is not limited to aqueous solution. It gives us much deeper understanding of acid-base behavior. So let's begin step by step. Bronsted-Lowry concept of acid and bases. But here student, the Bronsted-Lowry theory was proposed by Johannes Bronsted, it is a Danish chemist, and Thomas Lowry, it is an English chemist, in 1923. But here student, according to this theory, an acid is a proton, mean H plus ion donor, and a base is a proton, mean H plus acceptor. So instead of focusing on hydroxide ion like Arrhenius did, the theory focuses on the transfer of protons between acid and base. Definition of acid and base according to Bronsted-Lowry concept. Registering Bronsted-Lowry acid, a substance that donates a proton in H plus to another substance, is called acid according to Bronsted-Lowry concept. And the second one, Bronsted-Lowry base, a substance that accepts a proton in H plus from another substance, is a base according to Bronsted-Lowry concept. Examples: first one, reaction between HCl and H2O. Reaction HCl plus H2O gave H3O positive plus Cl negative. Explanation: HCl donates a proton in H plus to water. So HCl is a Bronsted-Lowry acid, while H2O accepts a proton in H plus from HCl. So H2O is a Bronsted-Lowry base. What is doing after the transfer of a proton, we get H3O positive, which is hydronium ion, which is the conjugate acid. Cl negative, chloride ion, the conjugate base. Second example, reaction between ammonia and water. Reaction NH3 plus H2O reversibly gave NH4 positive plus OH negative. Explanation: NH3 accepts a proton in H plus from water, so NH3 is a Bronsted-Lowry base, while H2O donates a proton in H plus to ammonia, so H2O acts as a Bronsted-Lowry acid. Product formed: NH4 positive is a conjugate acid, OH negative is a conjugate base. Now, concept of conjugate acid-base pairs. But here student, every acid-base reaction involves two acid-base pairs, known as conjugate pairs. A conjugate acid is formed when a base gains a proton, while a conjugate base is formed when an acid loses a proton. Let's understand with an example. Reaction HCl plus H2O reversibly gave H3O positive plus Cl negative. Now, substance, role, conjugate form. A substance is HCl and his role is an acid, and Cl negative is conjugate form, is a conjugate base. Because conjugate acid base is formed, conjugate base is formed when an acid loses a proton. Here HCl lost a proton. And second substance is H2O. Its role is a base, and H2O positive is a conjugate form. Is a conjugate form, which is a conjugate acid. Thus, conjugate acid is formed when a base gains a proton. Here, H2O gains a proton. So, HCl, Cl negative, and H2O or H2O positive form two conjugate acid base pairs. Example: acid base reaction between acetic acid and ammonia. Reaction C3COOH plus NH3 reversible gap C3COO negative plus NH4 positive. Explanation: C3COOH donates a proton H plus. It is a Bronsted-Lowry acid. NH3 accepts a proton H plus. It is a Bronsted-Lowry base. Conjugate pairs: acid C3COOH, conjugate base C3COO negative, base NH3, conjugate acid NH4 positive. Amphoteric nature of water. Water is a very special compound. It can act as both an acid and a base depending on what it reacts with. This property is called amphoterism. Let's see how. First one, when reacting with HCl, reaction HCl plus H2O give H3O positive plus Cl negative. Here, water acts as a base, accepts a proton. Second one, when reacting with NH3, reaction NH3 plus H2O reversibly give NH4 positive plus OH negative. Here, water acts as an acid, plus donates a proton. What is doing? Therefore, water is called an amphoteric substance. Now, proton transfer and Bronsted-Lowry reaction. General representation: Ha plus V reversible gap A negative plus Hb positive, where Ha is a proton acid, mean proton donor, B base is a proton acceptor, A negative is a conjugate base, and Hb positive is a conjugate acid. Now, advantages of Bronsted-Lowry concept. First one, it explains acid-base behavior in both aqueous and non-aqueous system. The second one, it does not require the presence of hydroxide ion in OH negative. Third one, it explains a reaction where no water is involved. Example, NH3 plus HCl give NH4Cl. Fourth one, it introduces the concept of conjugate acid-base pairs, which helps in understanding reaction reversibility. Limitations of Bronsted-Lowry concept. First one, it only applies to substances that can donate or accept protons. And the second one, it does not explain acid-base reactions that do not involve proton transfer. Example, reactions explained by Lewis concept, like BF3 plus NH3. So, my dear student, this is all about today's lecture on Bronsted-Lowry concept of acid and base. I hope you understand. So, if this lecture will help you, then don't forget to like the video, subscribe to the channel for more chemistry lectures, and share it with your friends. Comment your question below. Take care and see you in the next class, inshallah. Thank you for listening.